Welcome. This is a summary of the status of the new solar cycle, Solar Cycle 25, as of the end of August 2020. You can see here we have a picture of the sun taken at the beginning of the month, which showed a few sunspots on the sun, but by the end of the month it had got rather quiet. Here we have a plot of the sunspot number as a function of time. In yellow is the daily sunspot number, in blue is the monthly average sunspot number, and in red is the smooth sunspot number, smoothed over a period of 13 months. The solar community defines solar minimum between solar cycles 23 and solar cycles 24 as December of 2008. And from this you can see that the sun went very quiet in the second half of 2019. So I suspect that the solar minimum is sometime during that period. That would make solar cycle 24 between 10.5 and 11.1 years long, which would make it slightly shorter than average. And that's usually a good indicator of a larger cycle to come. At the moment, the monthly average sunspot number is seeming to follow the so-called SC model, the more conservative of the two models, and so that would indicate that we have an average to below average solar cycle to come. We've heard quite a bit over the last few years about the fact that this minimum that we've been just going through is so much lower than any previous minimum. Well, that simply isn't true. Here's the total solar radiance over the last 18 years. And I've put dashed lines here, one at the base of the orange curve, which shows the minimum in 2008-2009, and one at the base of the red curve, which is the minimum for the between the current two cycles. And you can see that the current cycle is significantly higher than the one back in 2008-2009. So this too is an indicator that solar activity is on the increase. Another fallacy that's been thrown around recently is that the solar magnetic field is weakening and therefore it's letting far more cosmic rays get into the solar system. Well, cosmic rays are monitored by neutron monitors around the globe, and this is typical of what we're seeing at the moment. If you compare the minimum in 2008 and 2009, where you had that very high flux rate of cosmic rays, with what's going on now, you can see that at the current time the number of cosmic rays is much lower, and therefore the solar magnetic field is keeping more of them out, not fewer. And that actually represents about a 2% change from last minimum. So let's try and put all this together into some sort of coherent picture. The increasing total solar radiance may be indicating a larger than upcoming cycle. Solar cycle 24 being shorter than average is also an indicator of a somewhat larger than average cycle. Solar cycle 25 so far is following the SC model, and that would indicate an average to a below average solar cycle. But remember, solar cycle 24 was well below average, so even a solar cycle that is below the average may well be much brighter than solar cycle 24's maximum. And so overall I would conclude that solar cycle 25 is to be greater than or equal to solar cycle 24's maximum. Well, in the month of August we had 11 sunspot regions. They're shown here. Now some of the sunspots were very small, and so I've actually marked those with a circle so you can see them more clearly. In the northern hemisphere we had 6 sunspot regions, 5 were from solar cycle 25. In the south we had 5 regions, 4 from solar cycle 25. So about 80% of the regions we saw in this last month were from solar cycle 25. The switch over from solar cycle 24 to solar cycle 25 is well underway. You can see it here in the plot. This is a plot of the number of sunspot regions by month over the last year and a half. In blue are the solar cycle 24 regions, and in orange are the solar cycle 25 regions. You can see up until solar minimum, as I say, late last year, the number of solar cycle 24 regions dominated quite significantly. However, since the turn of the year, the number of solar cycle 25 regions has far outstripped the number of solar cycle 24 regions, which seem to be continuing to decline. And as of this morning, we had our first September new sunspot region, and that too was a solar cycle 25 region. There's another way of looking at this, and that's counting the number of X-ray bright points. These are magnetic bipoles that are not large enough or strong enough to create a sunspot, but still reflect the polarity of the solar cycle that they're associated with. If you just look at the plain number of bipoles, they've been on an increase since September or October of last year, which is where I've been placing the minimum. But interestingly, the percentage of solar cycle 25 associated bright points has been increasing with respect to the number of solar cycle 24 bright points. In January of 2019, there was over 60% of the bright points were from solar cycle 24. As of now, that percentage is reversed. There's over 60% solar cycle 25 bright points. Now let's do what I'm sure most of you really wanted to be looking at this video for, and look at some movies of what the sun's been doing over the last month. We'll start with a white light image from the HMI instrument on the Solar Dynamics Observatory. In these movies, 1 second is equal to approximately 1 day, so they're vastly speeded up. The spots will move from east to west, or that is from left to right. You may have to run through the movie several times to see all the spots, and some of them are going to be so small and so short-lived that you may not be able to see them. One of the things you may notice in these videos is there are several frames which seem to go dark, or something moves in front of the camera. Now what can that possibly be? Well, it turns out it's us. The Earth at this time of the year sometimes gets between the satellite and the sun, and so the sun goes into eclipse behind the Earth. You can see 3 successive frames here taken a minute apart, showing that very effect. Now the limb of the Earth is not a sharp line because the Earth has an atmosphere. So this dimming towards the bottom of the screen here is actually different layers of the Earth's atmosphere absorbing different amounts of the ultraviolet light of these images. So next we're going to take a look at a magnetogram movie. This is also from the Solar Dynamics Observatory HMI instrument, and this instrument uses the Zeeman effect to give you the strength and location of strong magnetic fields. Again, the movie is about 1 second per day, but not all magnetic regions produce sunspots. This is why you can see far more regions here than you could see in that optical picture earlier. Only 2 of these regions actually had sunspots, and it might surprise you which ones. It is these. They are neither the largest regions, but this magnetogram movie shows you all the magnetic features that are on the sun, and that is often more important than whether something had a sunspot or not. Next we're going to move higher in the atmosphere and look at a chromospheric movie. We're going to use the Solar Dynamics Observatory AIA instrument and look at helium-2 304. Again, the movie is 1 second per day, and the temperature of this line is about 50,000 degrees Kelvin, which might seem hot to you, but however, as far as the sun's concerned, it's relatively cool material. What we're going to look for here is particularly the eruption of prominences above the limb. I've got one marked here, and there's several around the disk. These prominences, when they erupt, can cause coronal mass ejections, and those coronal mass ejections in turn can cause geomagnetic storms here on Earth. So they're very important to look for. Next, we're going to take a look at the corona, and for that we're going to go to the Solar Dynamics Observatory AIA instrument and look at the 193 angstrom band. This is equivalent to about 1.2 million degrees Kelvin, so this is pure corona. And in this wavelength, the active regions and sunspot regions appear very bright. However, there are also some dark areas here. You can see two prominent ones at each of the poles. These are coronal holes, and this is where their magnetic field lines are open, and the high-speed solar wind can stream out from the sun and eventually reach the Earth. Last but not least, we're going to look at the outer corona. For this, we go to a different spacecraft, the SOHO spacecraft, and use the LASCO instrument there. Now, in the middle of this dark circle is the size of the sun that we've normally been looking at so far, and the bit we're interested in is around that. We're looking for eruptions above the limb of the sun, those prominence eruptions that we were talking about, and you'll see large bubbles moving out very quickly. Now, those are the things, if they should hit the Earth, that can produce geomagnetic storms. So see if you can count how many there are. Well, let's draw some conclusions from all of this. The sun is slowly becoming more active. It's well past minimum and beginning its rise towards the peak of solar cycle 25. The maximum of that cycle should happen in the next 4 to 6 years. And my forecast based on the tea leaves that we've been reading so far is that solar cycle 25 will be larger than solar cycle 24. So thank you for listening, and until next time, goodbye.